Yes, welcome to today's episode of Physics UTME class with Math Mind Science Academy. And I'm hoping to give you guys more than what you know in the class today. So there are some concepts that we'll be talking about, and I'm hoping it's probably 15 questions and even move to a different topic today. The rate at which we are moving in physics, I love it so much. But I'm still contemplating if we'll be able to cover enough this cracking. Okay. Who else is experiencing that? Khadija Tijani. Okay, Ajay Abdullah is not experiencing it. Is it clear now? Khadija Tijani.
Yes, sir. Connected out.
Khadija Tijani, I'm going to make you the class captain for maths and physics. You're taking note of those people that are in class for this week. So taking note of those that are in class. You write their name. Those that are in class, you write their name. Before you end the class, you write the name of those that are remaining in the class. Because I see that you are very, very active in class. So I don't understand us. It's cracking, sir. It's not cracking. It's cracking. It's better. So,
Yes, sir.
thank you so much.
Yes, sir.
I don't want to make people that I know before. So I don't know say I'm doing cheating. So that I can pick. So that when you know write the name of people that I know before, I will tell them that you can see I know you before, but you're not joining my class.
Yes, sir.
Or do I know you?
No, sir.
Yeah, great. But I know you already. I know you now. Now, in our last class, we discussed a lot about all these guys, and I still have the materials since the start of the class. Wow. It's been a long time. Wow. You guys want this material, I know you want it so much. But I'm that lecturer that does not give us his material because I want it to come to class. I want to work my video on YouTube. Thank you so much for your support. We've moved to like 190 something subscribers on YouTube now. And we have over close to 3,000 views on YouTube. So before you YouTube start paying money, now become a YouTuber. Okay. In our last class, we discussed about this equation of motion. And I'm happy that, and I asked you guys to go and memorize these formulas. Did you memorize it? You don't know it before. So what I'm going to do is start solving bit by bit. We'll start solving the questions bit by bit. So we'll start with the first question. An Air Force jet flying with a speed of 335 meters per second. So the speed S now. I'm using S because I know where the question is tending to. Assuming it is distance, I will have used D as my S in this case now. But it says speed of what 335 meters per second. Always write your units. Very important. You see that anytime I write stops, I write units. I would always write units. Can you see? 800 kilometer, 800 meter. Even with the fact that I was explaining 20 meters per second. Can you see? 70 kilometer. You cannot catch me not writing units. I will always write units. There's no how I'll write some and not write units. You start watching for where I'm not going to write units, and you tell me that you did not write units, yes, sir. So an Air Force jet flying with a speed of 335 meters per second went past an anti-aircraft gun. How far is the distance? How far? That's the question. How far? You see that when you ask some guys how far, when they want to respond, they say 500 kilometers. Again, how far? I say 10 kilometers. It's because that how far is asking for a distance. Is the aircraft 5 seconds? That's the time. Later, when the gun was fired, this question is a simple speed is equals to distance over time question. Very simple. Speed is equal to distance over time question. So our speed is 335 is equal to distance unknown over 5. That's our seconds. So we cross multiply. Distance is going to be 335 times 5, which is equal to, don't stress yourself. Someone already did it for us. Oh, let me pin the calculator to my 335 times 5. Somebody did it for us already, so let's confirm. 1,675 meters. And that's option D. But I'm not planning to solve all the question in that order of 1 to 15, no. So I'm going to change my order. I want to solve the first question first because the first one has to do with the first formula, S equals to D over T. So this year, JAM just gave us a very simple question and, very simple bonus mark. Now, let's take the first example, which is a 2014 question, question 7. So this is going to be the second question I'm going to solve today. 14 question 7. So this is the question here. Okay. Don't worry. 2014 question 7. It says a car accelerates uniformly from rest at 3 meters per second square. Its velocity after traveling a distance of 24 meters is A, 144 meter per second, B, 72 meter per second, C, 36 meters per second, D, 12 meters per second. 2014 question 7. Now, the way I like to work is I like to work by writing out my parameters. I'm going to write out the parameters. You can't accelerate uniformly from rest. I already told you that anytime you hear the word a car start from rest, it means your initial velocity U is 0. This U stands for initial velocity. The velocity at the start of what of the journey. For this question now, that car is starting from rest. It was actually at rest before the whole motion started. So our initial velocity is what? 0. U. So in this case, you think that the initial velocity was not given. It's actually given because it says that what? It starts from rest. Also, anytime you hear the word, a car accelerating from blah, 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 and comes to rest or stops, when it comes to rest, it means that what V is equal to 0. So when it starts from rest, starts, U is 0. Stop, V is 0. Is that correct, guys? Good. In this case now, our U is 0. And we are given the rate of acceleration, A, which is 3 meters per second square. Its velocity, that's final velocity, V, after traveling the distance of 24 meters is, we have to look for that velocity. After going a distance S, which is what? 24 meters. Now, we have 4 basic formulas. B is equal to U plus AT. S is equal to UT plus half AT squared. And V squared is equal to U squared plus 2AS. And S is equal to 1 over 2 U plus VT. Now, of these 4 formulas, which one is most suited for this question? We need a formula that does not have T inside it. And that formula is this third formula. It's the only formula that does not have T. So it means the guy is the first formula, the guy is the second formula, the guy is the third formula, like fourth formula, you can only use the third formula because it's VU8S. So we say V squared is equals to U squared plus 2AS. V squared is what we're looking for. So U squared is 0 squared plus 2, our A is 3, and our S is 24. So V squared is equals to 2 times 3, which is 6, and 6 times 24 is 144. We have to look for V, not V, so we take the square root. Take the square root. So our V is equal to 12 meters per second. And that's option D. Is that clear, guys? Now, so this is clear. Let's quickly come here and solve question 12 and question 15. Question 12 says a motorcyclist traveling at 30 meters per second. That's the initial velocity. Now it's not from rest now. It is traveling at, that is what is using to travel. What's this? 30 meters per second. It's not at rest now. Has to apply his brakes when he is 50 meters from the traffic. Now the traffic distance S is 50 meters. It says start to apply his brakes when he is 50 meters from the traffic light. That has just 100. If you just reach the traffic lights, his acceleration is, oh, this question is not really the question we are looking for. Okay. Mm. Mm-mm. Mm-mm. Question 7. Hey, let's just solve it. Let's solve it. Don't worry. Let's solve question 12. We are still going to solve, make sure we solve everything. But I'll just explain the concept here. A motorcyclist traveling at 30 meters per second. So now write out the parameters. Now, a motorcyclist traveling at 30 meters per second, that's the initial velocity. Is that clear? Do you understand how it is initial velocity? Because that is what the, the motorcyclist is traveling with. Starts to apply his brakes. Now, when in the car, the component responsible for the increase in velocity, the component responsible for the increase in velocity is the accelerator. It is called the throttle, or you call it accelerator. When you press it, the speed increases. If you are very familiar with cars, the person driving will say, I just press the gas, it's the gas, it's the gas. And it increases the speed. And you hear that sound. Now, that's increase in what? Speed. The component responsible for decrease in speed, that is called the brake. So you can drive the car. If it's a manual car, you have three components down the steering. You have the clutch, the brake, and the throttle. I can't see your screen. That's your network code. The screen is blue. If you can see my give me thumbs up. Mm-hmm. So you have to do my again, right? Now, the brake is always on the center. So you can say CBT. You can use that one to code it. So when there's an emergency, you need to quickly press the brake. You know, I already know where the brake is. The brake is down the middle. But if it's a man, it's an automatic car. You only have the brake and the throttle. You use your right leg, your right foot to control this, and your left foot to control this. This one you use the right foot only. So that you don't use the left foot to press the brake and the throttle. So it's like you are pressing the brake or you're not pressing the brake. You are pressing the throttle, you're not pressing the brake. You understand? So brake and throttle. The most important thing here is that the brake, it causes the motion to decelerate instead of accelerate. So when you press the throttle of the accelerator, you are accelerating. The velocity is increasing as the time is increasing. But once you press the brake, you are decelerating. The velocity is reducing as the time is increasing. You are reducing the speed. Do you get it? So in this case now, it says that a motorcyclist traveling at 30 meters per second starts to apply his brakes when he is 50 meters from the traffic light. So his distance from the traffic light is about 50 meters. So from here, the journey here is, you know, here is 30. So the distance is 50. We shall know that Isha is not going to, it's not like Nigerians that they will go against the traffic rule. No, it's going to stop before the traffic light, right? So it's going to stop here. When the velocity of an object stops, sorry, when the motion of an object stops, what happens? V. It's always what? Zero. When an object comes to rest, or when the object stops, what happens to the final velocity class? It's always what? Zero. Don't forget that, please. So the intuition here is that start to apply his brakes when he's 50 meters ahead from the traffic light that has just turned red. If he just reached the traffic light, his deceleration is. So now the question is asking us for what rate is speed reducing with time? Do you get it? At what rate is his speed reducing with time? So the formula still remains v squared equals u squared plus 2as. We just need to solve for a using the formula we have here. Quickly, guys, solve and tell me the answer for you quickly. Excellent. Now, you guys should see this. Our v squared is 0 squared. Our u is 30 plus 2 times a times s, which is 50. 30 squared, sorry. Now, here we have 30 squared. Bring it here. That will be 900 is equals to 2 times 50. That's 100a. Now, this is supposed to be minus. Divided by 100, divided by 100. So my a is negative 9 meters per second squared. Now, this negative is because it is decelerating. When you're doing our deceleration, it's always of negative. Do you get it, guys?
Sir, it's not in the option.
It's not in the option here. Question 12.
Minus.
It's
Uh,
here, 9. They don't indicate minus. Don't worry. The minus is
okay.
just telling us that it's decelerating. Do you understand?
Okay.
Mhm. Now, question 15. It says a train. So we just take the ones that we've answered. We've answered 12. We want to answer 15 now. A train with an initial velocity of, you can see, very simple. Our initial velocity U is what? 20 meters per second. Question 15. Is subject to a uniform deceleration of 2 meters per second. Our A is 2 meters per second squared. It means the rate at which the object is trying to come to stop is 2 meters per second. The time required for the train, the time required to bring the train to a complete halt is, you're asking for T. Now, guys, what formula can we use? We only have U, we have A, we have T. What formula can we use?
The first formula.
We don't have V now. Do we have V?
Yes, it's equals to 0. Because
How do you know it's equal to 0?
it's coming to a
Because
stop.
it's coming to rest or a stop. You get it? Alt also means stop. So V is what? 0. So this is the first formula. V is equal to U plus 80. 0 is equal to our U is 20. Because it is 2, so it's a minus 2T. Minus, don't forget it's that's what I'm putting the minus. So bring this one here. 2T is equal to 20. Divided by 2, divided by 2. Our T will be 10 seconds. So the answer is what? 10. 15 B plus C. Yeah, that's correct. Is that clear, guys? Is it clear, guys? Excellent. 1 minute, please. 1 minute. As long as it's not clear, okay. Okay. Let's come to another example. So I have question next. Question next. I don't know the next number, so let's call it next. A car from moves with a uniform system of 30 meters per second square for 20 seconds. Calculate the distance covered at the end of the motion. At the motion. Consider to likely be your screen or network. I'm sharing my screen and it is busy. A car starts from rest again. Our U is 0. And move the window acceleration A is 30 meters per second square for 20 seconds. Calculate distance covered just to find S. Distance. Distance is in that S. So what I'm going to do is out of this three formulas, top formulas, second formula. So S is equal to UT plus half AT squared. You can't see me very well. Is it cracking? Is it cracking at everybody's end? Or only at Jayab? Can you hear me? Nafisa, can you hear me very well?
No, sir.
Eh. Is it better now?
I can hear you.
Okay, good. Now, in this case, we say our S, which is the unknown, is equal to 0 times 20 plus half times 30 times 20 squared. This is 0. Here, 1, 30 is 15. 15 times 20 squared, 400. What is 15 times 400? That's 6,000 meters. And that is correct. So now I want to make use of this formula. Let's go to question 7, 8, 7. A particle starts from rest, U is 0, and moves the constant acceleration of A is 0.5. The distance covered by the particle in 10 seconds is just to find S when the time is. I didn't write the unit here because of the space. The formula is S equals UT 0 times 10 plus half A then T squared, 10 squared. So this is 0. So we have 0 plus 1 over 2 times 0.5 times 100. 0.9 times 100 gives 50 divided by 2. That's 25 meters. Option C. Is that everyone? Thank you. 7. Done and dusted. Option 8. What starts from rest? Use 0. And move the uniform acceleration of A is 6. What distance does it cover in the third seconds? Yes, questions like this, I want to solve them. So I'm going to move it to a different screen. Okay. Just let me ask you to just read first of all. Let's come to question. Now, the question says, the question is question 8, which is 1992, question 4. Okay. Let's write the question. This one says question 8. Question says starts and moves with uniform acceleration of 6 meters per second square. What distance does it cover in the third second? I'm not sure if why is going to test you with questions like this. I'm not sure. Have you seen questions like this, right? I'm not sure. I think this is part of exam syllabus. So let's not asking for particular seconds. And also there's a topic called instantaneous velocity. Right is also going to test you on that. The same like that will do, the same that will do testing on some questions. So I'll do something like this. I'll give you first method. But why you first method, I'll give you the add method first. The body starts from rest. My U is 0. Somebody is saying something. I didn't see that. Side is cracking. Is it cracking now? Is it cracking now?
Yes, sir. I can hear you.
So it is cracking. Oh.
Mm-hmm. Okay.
Yes, sir.
What is actually recording is that it's not network. It's guys network. No, I'll go and get standing because of the guys. So I have to speak. Should be better now. Is it better now?
Yes, sir.
Excellent. Body starts from rest and moves with uniform acceleration of 6 meters per second square. With what distance does it cover in the third seconds? Yeah, our initial velocity U is 0. Acceleration A is 6 meters per second square. Our distance S is unknown. But what distance? Distance in the third seconds. Now, what we are going to do to get the distance in the third seconds, you have to do distance
Like this.
when time is 3 minus distance when time is 2. So you calculate two distance now. Two distances. The distance when your time is time 2, you're going to remove it from the distance when your time is what, times 3. Very complex, Abi. That's how you solve questions like this. So that's the only way to solve it. Don't go and say your T is 3. No. It's not asking you for distance when the time is 3. No. At that third seconds, what is the distance? Distance will lower. So what distance to cover from 1 to, you have to remove it from the distance at that third seconds. That's when you know the distance. Do you get it? So from here, let's decide on the formula we want to use. We have to use the formula S equals UT plus half AT squared, right? For you to know what you are doing very well, anytime you have your U to be 0, don't bother about this side. It will be 0 completely. Just focus on S equals half AT squared. Just focus on this. Do you get it? So S at time 3 now is 1 over 2 times 6 times 3 squared. 2 here 1, 2 in 6, 3. That's 3 times 3 times 3. That's 18 meters. Now your distance at time 2 is going to be 1 over 2 times 6 times 2 squared. 2 here 1, 2 in 6, 3. 2 squared is 4. 4 times 3, that's what? 12 meters. So your distance at time t now is going to be 18. Ouch, sorry. 3 squared is 9. 9 times 3 is 27. This one is supposed to be 27 meters. Your distance at time 3 now. So your third distance now is going to be what? 27 minus 12, which is what? 15 meters. Is this clear, or should I explain again? Is it clear? That thumbs up is clear, huh? Alhamdulillah. It's not clear. Okay, I can see one person telling me that it's not clear. So Yusra Lawal, so it's not clear. Because of Yusra Lawal, I'm going to explain again. Like I said, Jimon. Okay. Because of you, I'm going to explain. Before you say I'm being partial. And because of Rakib too. Now, these are our parameters. A body starts from rest and moves with uniform acceleration of 6 meters per second square. From rest, acceleration, what distance does it cover in the third seconds? Distance the third seconds. We have to get the distance at time 2, at the distance in the second seconds and the distance in the third seconds. To get the distance in the third seconds, you have to get the distance at time 2. You now remove it from the distance at time 3. That's how you know the distance it is in the third seconds. How do we get that? We use the formula S is equals to UT plus half AT squared. How do I know the formula I'm going to use? I have U, I have A, I have my distance is what I'm looking for, and I have time, 3 and time 2. And that's the only formula that fits in with what? With this unknown. So to get the unknown. Because our U is 0. If you multiply 0 times whatever time you have here, this guy here will be 0. So we can just eradicate it and just focus on S is equals to half AT squared. Because our U is 0, the object starts from rest. Is that correct, guys? Also, your formula V is equals to U plus AT. If your U is 0, just ignore this guy and focus on V equals AT. Also, your formula V squared is equals to U squared plus 2S. Your U squared is 0. Don't forget about this guy and focus on what? V equals 2AS. You can do it like that. If you know what you are doing, sharp, you will save time. Do you understand? Now, we want to get our distance when our time is equals to 3. So we use the formula 1/2 times what's our A, 6 meters per second, 6, times what our T, 3 squared. So 2 here, 1, 2 in 6, 3. So what is 3 squared? 9. 9 times 3, that's 27. So distance at time 3 is what? 27 meters. At time 3 is different from distance at the third seconds. It's different. Now, distance at time 2 now, that's 1/2 times our acceleration is still 6 times our time now has changed from 3 to 2, so 2 squared. The formula is S equals half AT squared. Don't forget. 2 here, 1, 2 in 6, 3. Now, 2 squared is 4. 4 times 3, that's 12. 12 meters. Now, to get the distance at the third seconds now, that will be distance at time 3 minus distance at time 2, which will be 27 minus 12, which gives us what? 15 meters. Is this clear? Khadija Taufik, please ask your question. We have so many Khadijas. We have another Khadija Tijani, and that's our class monitor.
No, that's actually me, sir. It's Khadija Taufik, not Khadija
Oh, okay.
Shalem.
Okay. What's your question,
Yes, sir.
Ma?
My question goes as, if it says we should find the distance in the fourth seconds, so we have to use the third and the fourth.
Exactly. Distance at time 4 minus distance at time 3. Yes.
Okay, thank you, sir.
You're welcome. Is this clear? Now, to mathematics students, I want to give you guys one expo. Math students, are you ready? Aisha Lawal, you did not attend my math class, Abi. Very good. You saw Lawal too. I say Aisha Lawal. Aisha, what's her name? Aisha, you know yourself. You did not attend my math class. You saw Lawal too. You did not attend my math class. Good. So this tip is for math students only. Math students, are you ready? Thank you, Jerry, math students. You attended, eh? I didn't see anything. You were so silent in today's class. You used to be very active in the chemistry task class. It's as if you are the only one doing the chemistry class. And always eager to ask you questions too. Since we left, since we didn't see shadow again. You are a civil rights student now. Now, Remember this formula, sum of AP. Who can remind me of that formula? Sn is equals to what? Formula, sum of AP.
Sn is equal to n raised to power minus 1.
No, sum of AP. No, I'm lost though. Sum of AP. The formula Tn is equals to A plus n minus 1d. Sum of AP now. If you want to sum it together, how's the formula?
I think n over 2 into
Mhm.
brackets A plus something.
Is
Oh,
it this?
R plus.
No,
I
sum
forgot.
of AP, not DPO, not DP. Is it this formula? I've forgotten too. Seriously, I've forgotten. I want sum of AP character. Yeah, go ahead, please, if you know it.
Is
The
it
n over 2 into bracket 2 plus
bracket A plus N?
10 over 2 into brackets.
2a plus
Bracket A plus.
Okay. Now, there is a formula that I sat down to work on to give me all these jargons, especially if it is a question that has to do with this formula. I'll give you the formula. Sn is equals to U plus A over 2, 2n minus 1. So this formula, I sat down to derive it. Hi, you're not sitting in textbook. Oh. I'm telling you. So if you are serious and ready, when we get to math class, I'm going to derive this for you. I'm going to prove it. So I use some knowledge of AP and GP and some knowledge of basic math. It's not really a complex math, don't worry. So let's put it and even check if it will give us 15 first before we now go ahead to see if we have time to prove it or not. Now, my U is 0, so I'll just say 0 plus my A is 6 over 2 into bracket 2. What am I asked to find? N S3 bar 3 minus 1. So 2 here 1, 2 in 6, 3. So that's 3 into bracket 2 times 6, 6 minus 1. That's 3 times 5, which is what? 15 meters. So that's the formula. You can see very easy and simple. But if you think that you have space in your head to put formula, you can put it sharp, sharp. Like you can say that everybody has forgotten the formula for AP and GP. So when we answer that question too, we'll see if we can use it. But for now, I don't want to stress you on how I got this formula. It is in So question 8, we'll solve question 8. Alhamdulillah. Let's move to the other one. So even if you forget the formula, you already know how to get it. Please, let me see what Benny Becker said. I know Benny Becker will be interested in that formula. We explain with that formula. So, okay, it's Al-Bashiri. Okay, so the formula is actually straightforward. You know, we've gotten the parameters before. We know our U is 0, our A is 6, and we have to find the third what? The third seconds. So just use it as 3 like that. N is 3. So S3 now is going to be equal to our U is 0 plus our A is 6 over 2 into bracket 2 times our N is 3. Just like you're looking for AP and GP like that now. Sum of clinical. Find the 8th term. You just take your N as 3 minus 1. 0 plus 2 year 1, 2 in 6, 3. 3. This Bodmer's rule, it applies to all mathematics and chemistry and physics. So, yeah, you cannot do 3 minus 1 first. To possible, you have to do 2 times 3, 6. Then 6 minus 1, 5. If you do 3 minus 1, 2. 2 times 2, 4. You get something totally different too. You have to do multiplication first. 2 times 3, 6. Then 6 minus 1, 5. Again. Then 3 times 5, 15 meters. You understand? So that's how you got the 15 meters. Is that correct? Thank you so much. So we have question 13. Let's come to question 13 here. So you want to write the formula? Sharp, sharp. Sharp, sharp. 1 minute. Just the formula only. In fact, go and watch the video. A car accelerating uniformly from rest at 4 meters per second square. A car accelerating uniformly from rest. Let's see. I want to stop on 13 here. Okay, we're on 13 here. Question 13. A car accelerating uniformly from rest. My U is 0. How far? That's S. Will it travel in the 5th complete seconds? S5. Can you see now? Uniformly from rest. A is 4 meters per second square. Now, if you want to use the normal formula, you have to find the S at t equals 5. You remove the S at t equals 4 from it. But I already help you guys now. We have the formula already, Abby. Remember, our role model, when it has 2 options, what is it going to do? You pick the one that is what? The easiest one. So let's use the easier one, please. Our S5 is equals to U plus A over 2, 2n minus 1. Our U is 0 plus A, which is 4 over 2, into bracket 2 times 5 minus 1. So 2 here, 2 into bracket 2 times 5, 10 minus 1. So we have 2 into 10 minus 1, 9. 9 times 2, that's 18 meters. And that's our answer. Option D. If you want to confirm if that answer is actually correct, very easy. What is the distance at? You know, we are going to use S equals half 80 squared. Don't forget. So S at times 5 now, that will be half times A, which is 4, times T squared, which is what? 5 squared. 2 here 1, 2 here 4. 5 squared is 20. Sorry, 2 here 2. 5 squared is 25 times 2, that's 50 meters. S4, which is 1 over 2 times 4 times 4 squared. 2 here 1, 2 times here 2. 4 squared is 16. 16 times 2 is 32. So we do 50 meters minus 32 meters. That gives us what? 18 meters. And it's still correct. Is that clear, guys? Good. So easy method, but easy method. Question 14. Yes, you can answer question 14, yeah? Question 14. Calculate the total distance covered by a train before coming to rest. Its initial speed U is 30. Before coming to rest, that's V. V is 0. With a duration of A 0.1. So I have to calculate the total speed. S unknown. Abi now? Total distance, not total speed, sorry, total distance. So what formula can we use? We can only use the last formula. V squared is equals to U squared plus 2S. V squared is equals to U squared plus 2AS. So 0 squared is equals to 30 squared plus 2 times A is going to be minus 0.1. Yes, also family retardation. Let me come here and write on a better screen there. Sorry. Question 14. I have my U to be 30 meters per second. My V is 0. My A is negative 0.1 because it is what? It is retardation. And we have to find S. So we use the formula V squared is equals to U squared plus 2AS. V squared, 0 squared. U squared, 30 squared plus 2A is negative 0.1. Very good, Al-Bashiri. Did you join the class late? Al-Bashiri has a very good question. How can we know the formula we are supposed to use? The formulas we have are just 4. V is equals to U plus AT. S is equals to UT plus half AT squared. V squared is equals to U squared plus 2AS. To know the formula to use, it depends on the parameters you have. From the question, we wrote out U, we wrote out V, we wrote out A, we wrote out S. A formula that has U, V, A, S. U, V, A, S. Can you see? U, V, A, but no S. So we can't use this. U, no V, we can't use this. So U, V, A, S. This is the only formula that fits that we can use. So that's how we do. 30 squared is 900, then minus 0.2S. So bring this here. This goes to 900, divided by 0.2, divided by 0.2. S is equals to 4,500 meters. Don't ask me how. When we get to decimal, I'll explain to you. You are still on fraction. But this one, I can answer this without even looking at the option. Option B. Option B. Now let's look at this. Another example, although we've solved questions on this already, but I just want to solve more. This is 1985, question 6. It says, if a car, Ajayabla, please start. Go ahead, please.
Okay. For that retardation or deceleration, why are we
Yes,
not putting the negative, or it does not matter?
I actually put the negative in the question when I was solving, but it doesn't matter. You don't need to indicate negative in your answer. The negative only indicates that there is a retardation going on. Do you understand? When I was solving, I actually put the negative sign. If you had solved the question without putting negative sign, it does not spoil anything. Just that in your final answer, you're going to have a minus, which you are going to remove. Do you understand? But when I was solving this question, I actually I indicated by putting a negative sign. This is not theory question. If it is theory question now, there's a way we do it. And yes, theory, yes, whereby you are submitting your answer. In this case, you just want to pick the option, and the options will most likely be positive numbers. So just work with removing the negative, even if you get negative as answer. And even if you eventually use negative in your question, just work with the positive answer. Do you understand?
Yes, sir.
So this is not why whether you submit your answer. No. They don't want to see that. But assuming it is theory question, you have to show them the negative sign and the effect of the negative. Do you understand? So the car starts from rest and moves with uniform acceleration of 10 meters per second square for 10 seconds. The distance it covers in the last 1 second of its motion is, now this is quite different from, it's the same thing, but the intuition is a bit different. 1985.6. The question says, if a car starts from rest and moves with uniform acceleration of 10 meters per second squared, it starts from rest. Solution. U is 0. A is 10 meters per second square for 10 seconds. Time is 10 seconds. The distance is covered in the last 1 second. Distance in last 1 second is. Now, this distance in the last 1 second is the distance between time 10 and distance between time 9. Who agrees with me? The whole journey takes 10 seconds. So you have to calculate the distance in the last 1 second. Within that 1 second, distance will cover. In that 1 second, yeah, that is when time is 9 and when time is 10, in the distance to cover, to travel, you have to subtract the distance at 10. You have to remove the distance at 9 from it. Do you agree with me? So you can use that formula to solve this. Again, don't bother yourself by doing S equals UT. Your U is 0 already, so just use half AT squared. So our X at 10 is going to be 1 over 2 times A, which is 10, times 10 squared. 2 year 1, year 5. 10 squared is 100 times 5, that's 500 meters. S at 9 is half times our acceleration is 10, but our time now is 9 squared. 2 year 1, 2 in 10, that's 5. 9 squared is 81. 81 times 5 is 405. So our S at the last 1 second is going to be what? S at 10 minus S at 9, which is what? 500 minus 405, which gives us what? 95 meters. Is this correct? Now, can we use that formula? Can we use our formula? Let's see. Smart formula. S10 is equals to U plus A over 2 to N minus 1. So 0 plus A, which is what? A is 10 over 2, then 2 times N, which is 10 minus 1. 2 year 1, 2 year 5. So 5 into 10 minus 1, 20 minus 1. So that's 5 times 19, which will be 95 meters. QED. Okay. So we can leave this part now and move to other type of questions. In this question now, example, whatever the number is, a car moves with an initial velocity of 25 meters per second. Yeah, that was second, not squared. The velocity. And reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? If you guys asking me for acceleration, this question is 2010, question 5. If you guys asking me for acceleration, you can use the formula A is equals to V minus U over T. Don't stress yourself. A car moves with an initial velocity U is 25. Reach the velocity of V 45 in 10 seconds, time 10. Just find it. A is equals to 45 minus 25 over 10. It is 20 over 10, which is what? 2 meters per second squared. So questions like this are actually very, very simple because this formula you have to use. Also, you can still use the formula. V is equals to U plus AT. Don't forget that this formula and this formula are gotten from the same way. So you can still use this. Your V is 45 is equals to your U, 25, plus your A, then your T, which is what? 10. Take this guy here. 45 minus 25 is equals to 10A. 20 is equals to 10A divided by 10, divided by 10. A is equals to 2 meters per second square. So they are the same. Do you get it, guys? Ajay, you have a question? So let's come to solve question 8. Question 6. A train has an initial velocity of this. U is 44 meters. An acceleration of this, our A, is negative 4 meters per second square. Its velocity V, Lanwa, after 10 seconds when T is 10. Very simple. Just use the formula V is equal to U plus AT. U is 44 plus A, negative 4, then T 10. So that would be 44 minus 40, which gives us what? 4 meters per second, and that's the answer, option B. Is that clear? Don't stress yourself. We come to question 10 here. We have a similar question here. A motor vehicle is brought to rest. Brought to rest. That means it comes to rest. Our V is 0. From a speed of, that's the speed it is actually coming from. So U is what? 15. In 10 seconds, T is 20, sorry. Calculate the retardation. This acceleration is still the same formula. A is equals to V minus U over T. 0 minus 15 over 20. So that should give us a 5 year 3, 5 year 4. That would be negative 0.75 meters per second. But it doesn't square it. It doesn't matter the negative. So just pick your option A, question 10. Is that clear, guys? I want to observe everything here. Okay. Put another example. Example, whatever the number is. Example next. Junior, it will be your network. If you can't see my screen, it's your network. I'm actually seeing my screen. So if you can't see my screen, it's your network. Example next says that a car moving with a speed of 90 kilometers per hour. A car, so you have to leave and join again, Junior. Moving with a speed of 90 kilometers per hour was brought to rest. Was brought uniformly to rest. Was brought uniformly to rest. Dear. By the application of what? Of brakes in 10 seconds. How far distance? How far did the car travel after the brakes were applied? A, 125 kilometers. B, 120 kilometers. C, 250 kilometers. D, 15 kilometers. So a car moving with the speed of our initial velocity U is 90 kilometers per hour. 125 meter, not kilometer. Meter. 120. Option B, 150 meter, 250 meter, 15 kilometers. So we have to convert this guy from kilometer to hour. You remember I told you 90 times kilometer to meter is times 1,000. Then hour to seconds is divided by 3,600. Just press calculator. 90 times 1,000. 90 times 1,000 divided by 3,600. 90,000 divided by 3,600. That's 25 meters per second. That's our initial velocity. We can't use 90 kilometers per hour, guys. Was brought uniformly to rest. So our V is 0 because it comes to rest. How far? Sorry, was brought to rest by the application of brakes in 10 seconds. Time is 10 seconds. So we have U, which is 25 meters per sec, V, which is 0, and we have T, which is what? 10 seconds. How far did the car travel after the brakes were applied? We have to find S. Now, if you only know the first three formulas, that V is equals to U plus AT, S is equals to UT plus half AT squared, and that V squared is equals to U squared plus 2AS. You might not know exactly what to do. You might first need to find A first, then now put that A into this place to find S. But that will be too stressful for you. There's a simple formula we can use, which is the fourth formula. That's why I like to tell my students that these formulas are not 3, they are 4. The fourth one is S equals half U plus V multiplied by T. I have a video of the proof of these guys on YouTube. How these guys came about. The video is on YouTube. So you can go and check if you're interested. But it's not important for your exam. Anyways. But if you want to write why it's important to write SSA. Now, we can use this formula. That's what I'm trying to say. Instead of this one, doing one first, then get the answer of A, then put it here to get S. You don't need to find A. You can quickly use this fourth formula to get your answer. S is equals to half U 25 plus V 0 multiplied by 10. So 2 here 1, 2 can multiply this 10 outside 5. 25 plus 0 is 25 plus 5, sorry, times 5 is brackets. That gives us 75 meters. So that's the distance. It's not there. The answer is not there. Yeah, come up.
So 25 times 5 is 125.
Not good. Not good to say. 25 times 5 is 125, is not 75. So option A is correct. So we have a question that we can use this answer to. The network is doing somehow. Can you hear me clearly, Khadija?
Yes, sir.
Okay, so if your network is not mine. Question number 10. Let's go on question 10. So question 9. An aeroplane lands on a runway at a speed of this. You have to so your U now is going to be equals to 180 times 1,000 divided by 3,600. Quickly get me the value of U. And it's brought to a stop uniformly. So V is 0. Very simple, similar to the same question. Brought to a stop uniformly in 30 seconds. T is 30. What distance? The same formula, the same method, it's just different in the values. So S will be equals to half whatever you get for U here plus 0 multiplied by 30. So 2 here 1, 2 in 30 is 15. Just do 15 times whatever the answer is. So what's the answer here?
50. 50.
50. Let me confirm. Not that I don't trust you. But you can see that even me, I'm doing it and doing it again. 123 divided by 3,600. 50. Thank you. So we just do 50 times 15. These guys here, there's a simple way to multiply guys like this, especially if one of it has a 0. Just do 5 plus 50 into 10 plus 5. So 50 times 10, 500. 50 times 5, 250. That's 750. That's our answer. So you can hold that one too. To be important and beneficial for you. So I believe that we'll solve every question on this sheet. 8, 9, 10. This have 11? No, not yet. 12, 13, 14, 15. So the only question left that we will not solve this question 11. Question, yes, 11 is the only one we've not solved there. We've solved 10, we've solved 9, we've solved 7, 8, 6. Have we solved 5? No. 4? No. 3? No. Have we solved question 1? Yes. Question 2? No. So we've not solved 2. We've solved question 1. Okay. So question 2, question 4 are not actually of this topic. I like to treat them in a separate topic. But question 11, we can solve it. We can solve question 11. So this is 6 already, and I want to introduce another topic today. Question 11. Okay. So for let me solve question 11, and I would explain another concept. Then we'll now move to. So for question 11, it says that the distance x meter traveled by a particle in time t seconds is described by the equation x is equals to 10 plus 12t squared. Find the average speed of the particle between the time interval t equals 2 seconds and t equals 5 seconds. A 60 meters per s, B 72 meters per s, C 84 meters per s, D 108 meters per s. Question 11. Now, in this question now, I want you guys to listen attentively. The distance s meter traveled by a particle is described by the equation. So we have this equation to describe it. So the distance is 10 plus 12t squared, right? Find the average speed of the particle between the time interval. So we have t2s and we have t5s, right? Are we together? So let's put our time is 2. Let's put it here. So s when t is 2 will be 10 plus 12 2 squared. Just anywhere you see t, change it to 2. That's what I want to do. 10 plus 12 2 squared is 4. That's 10 plus 4 times 8. Sorry, 4 times 12. That's 48. That gives us what? 58 meters. Is that correct? When it is 5, uncle, when our t is 5, again, s at t equals 5 will be 10 plus 12 into bracket 5 squared. That will be 10 plus 12. 5 squared is 25. So 25 times 12 is 20 to 40. 300 plus 10. That's 310 meters. Now, when we say average speed, it's different from speed. Average speed is the total distance covered divided by the total time. Do you get it? Total distance by total time. Now, the distance between 5 seconds and 2 seconds is what? 310 minus 58 distance. Abi? That would give us what? If we subtract 252 meters. Now, time between the 310 meter to 58 meter is what? 5 minus 2, which gives us what? 3. So the average speed now will be equal to total distance, 252, over total time, 3, which would give us, so you need to divide by 3. That gives us 84 meters per second, and that's the answer, option C. Now, I can see thumbs down. I know that it's not clear. Al-Bashiri, is it clear up to this point? No, okay. Now, the question says the distance x meter, 30 minutes, traveled by a particle in time t seconds is described by the equation. So now we are talking about particle, and we have the equation for the particle, 10 plus 12 t squared. We have to find the average speed between the time interval t equals 2 and t equals 5. So we have to get the distance when t is equals to 2 first. Anywhere we see t in this formula, we're going to change it to what? To 2. So 10 plus 2, 12, sorry, 2 squared, because t is 2 there. That would be 10 plus 12 times 4, which is 10 plus 48. 12 times 4 is 48, which is what? 58 meter. So at time 2, our distance is 58 meters. Now at time 5, because the interval is 2 and 5, we have 10 plus 12, 5 squared. We have 10 plus 12 times 5 squared is 25. You have to do the bracket first, exponents here. That I'm doing. You can't do 10 plus 12 first. You have to do the exponent. Don't forget order of operation. 5 squared is 25. Then you have to multiply before you add. 12 times 25 to 10 plus 12 times 5 is what? 300. So 10 plus 10, that's 310 meters. So at time t equals what? 5 seconds. So we've gotten what we need. Just that we want to find the average speed. What is the average? When we say average speed, guys, average speed is total distance over total time. Now the guy says, find the average speed of the particle between the time interval 2 and 5. It means we want the average speed of 3, 4. So the interval between time 2, time 3, time 4, time 5. So between this interval, we want it. So we have to remove this 2 from this to give us this interval. Do you get it? The interval at 2, when the time is 2, it is 58. Here, it is 310. So what will be this length? It is remove 58 from what? From 310. So the distance now is going to be 310 minus 58, which is 252. Then the time also is from 5 to what? To 2, which will be what? 3. So the average speed is what? 252 divided by 3, which is what? 84 meters per second. And that's the answer, option C. Is this clear? So solve question 11 like that. Alahal Ventures, I hope you are a male or a female. Are you a male or a female? Alahal Ventures. So what is left for us to solve? Is question 2, 3, 4, and 5. If you are somewhere around there, Oshogbo, Oshun, you know that the mercy of Allah is upon us. I mean, I like to sleep when it wants to rain. So we only look at one more question. I'll end the class. What do you think? We still have 2 physics period this week. Don't let us take everything at a time. So one last question before we end the class. This is 2000 question 8. The velocity v of a particle in a time t is given by the equation v is equals to 10 plus 2t squared. Find the instantaneous acceleration after 5 seconds. A, 10 meters per second square. B, 15 meters per second square. C, 20 meters per second square. D, 60 meters per second square. If you have just gone to an ordinary secondary school, you'll be surprised to what kind of question it is. But they are a secondary school that they are using a blended syllabus. You will have exposed you to something like this before. So instantaneous acceleration. Don't be scared. Don't be scared. It's very simple. Very, very simple. Now, we have the velocity. It's given to us in a particle form. V, which is equals to what? 10 plus 2t squared. And you have to find the acceleration when t is what? 5 seconds. Very simple. The first thing you are going to do is something called differentiation. You have to differentiate this particle. So we have to get something called dvdt. Don't worry. I'm just saying it so that I can scare you. It's very simple. This dvdt is rubbish. It's very simple. Don't worry. This guy that has 10, if you differentiate it, differentiate means transform it. If you change 10, because it does not have anything in front of it, it will become 0 plus this 2t squared. If you transform it, if you differentiate it, if you have 5t raised to power 3, the way you do it is use the 3 to multiply 5. It becomes 15. See, then you remove 1 from this 3. It becomes 2. Is that clear? Let's say I ask you to do 15t squared now. What do you do again? Use 2 to multiply 15. That's the first thing. 30. See, then remove 1 from 2. 1. So you don't need to put that 1. So that's exactly what we want to do here. Now use 2 to multiply 2. That's 4. See, then remove 1 from this 2. It becomes 1. You don't need to put it. So the differentiated form of dvdt, now the particle v has now changed to dvdt. That is what? 4t. Now just put your value at t equals 5 inside it. Anyway, you see t need to 5. So 4 times 5. And that gives us what? 20 meters per second squared. And that's how you solve instantaneous acceleration. So in our next class, we'll still have 5 minutes. 5 minutes. What can we do? Okay, let's continue. I wanted to say in our next class before. So this is how you do instantaneous acceleration. They can ask you instantaneous velocity as well. They will give you a particle now. And they like this one now. That's the one we have here. 10 plus 12t squared. They will tell you that this is the particle for the speed, for the distance. Calculate the speed at time something. So it's also possible. So it's the same method. Let me coin that kind of question for you so we solve it. The distance x of a particle in time t is given by the equation x is equals to. Go ahead, Dosumu.
So how do you get it for?
The 4. You were not in class then. Okay, I'll do it again. No one. 3t cube plus 4t minus 3t 5t plus 17. Find the instantaneous velocity after 3 seconds. Now, when we say instantaneous velocity, it is the velocity at a particular instant of time. You can see they're giving us the time at 3 seconds, at 5 seconds. It's the velocity at a particular instant of time. In this question now, it says the distance x of a particle in the time t is given by this meters. Find its instantaneous velocity. Now the distance x is what? 3t squared plus 4t squared minus 5t plus 17. Now we need to find the x over dt. We need to differentiate it. This dx over dt is same as our velocity. This dv over dt is same as our acceleration. Acceleration is what? Change in velocity over time. Can you see? That's why we think of differentiating it. This one here, that's why you think of differentiating it. Now dx dt, to get this, there's a 3 here. You are going to multiply this 3, I made that the sum, this 3 by the number in front of it here. So 3 times 3 is 9. See. Then this 3 here, you are going to remove 1 from it. So it's going to become 2. Plus this 2 times 4, that's 8t. Then remove 1 from this one, it becomes 1. Don't put it. Minus this t here, there's a 1 here. 1 times 5, 5. Then t 1 minus 1, that's 0. So that t becomes 0. It will go. 0 to power 0 is 1. It will go. This one that does not have t becomes 0. Don't bother yourself about it. If it does not have t, it becomes 0. So this is your reduced form. So this is your differentiated form, a transformed form. Now you're not going to put your t to equals 3 seconds. So you're going to put 3 seconds there. So it will be 9 into bracket 3 squared plus 8 into bracket 3 minus 5. 3 squared is 9. 9 times 9 is 81. Plus 8 times 3 is 24 minus 5. 81 plus 24, that's 105 minus 5. That gives us 100 meters per second. And that's the velocity. Is that clear, guys? Somebody said my network is bad. Are they being fair or keep? I think it's more likely be your network because everybody is giving thumbs up. So you have to go and check the recordings. Who is this Alal Ventures? I'm interested. Who is Alal Ventures? What's your name, Ganga?
Abdul Hakim Muhammad.
Jamil. How are you?
Alhamdulillah, sir.
MashaAllah. Okay. Now, if that is the case, we have how many minutes? On dot, Ganga. Like you know, now I like to drop at a particular point, then we take it from that point. Now, quickly. You see this formula? V is equals to U plus AT. S is equals to UT plus half AFT squared. V squared is equals to U squared plus 2AS. These three formulas. We are going to change it because these formulas are only useful under linear motion. When we change to up and down motion, which is also known as vertical motion, it changes to, the most important thing is that your A is going to change to G. Now we have two types of G. The G can be plus or minus. A is going to change to G, either plus or minus G, depending on when you are going up or you are coming down. I'll explain that. Your S, which is your distance, is going to change to H. That's the only thing. So for up and down motion now, the formula is going to be V is equals to U plus GT. H is equals to UT plus half GT squared. V squared is equals to U squared plus 2GH. Or V is equals to U minus GT. H is equals to UT minus half GT squared. V squared is equals to U squared minus 2GH. So in the next class, I'm going to tell you when it's going to be plus, when it's going to be minus, inshallah. So I'll see you guys in the next class. Thank you so much for your outstanding eagerness and outstanding responsiveness. Somebody raised a hand. Khadija, Oluwabukola, you have a question for me?
It was a mistake, sir.
Okay. Okay. This emoji is not feeling. It's not going good.